quite excited about today's chat. I have with me uh, two people from a company that needs no introduction, Grafana. They've been around for ages, pretty much since the start of cloud native computing, DevOps, and all of that, movement, and pretty much been the go-to tool when it came to visualization. And they've been up to a lot of cool new stuff, which is what we want to get into today. So I have with me, I'm going to try to get the name right, so bear with me. Let's see what I do. Vasil Kaftandzhiev. He's the
Amazing.
staff product. He's a staff product manager at Grafana. And I also have with me Pete Wall, who's the senior software engineer at Grafana. Vasil and Pete, great to have you. Thanks for joining.
Yeah, thank you for having us.
Dwayne, thank you very much for having us.
All right, quite looking forward to the conversation. And I'm sure many of our listeners as well and viewers quite curious to know what you guys are going to talk about and unwrap here. Want to start with you guys yourselves first as professionals, as builders. What's your story? How did you guys get to Grafana? What are your interests? If you could start with Vasil first.
Thank you. So what happened was, at some point I was working in VMware. Funny fact, and I don't want to spoil the surprise, Pete was working there too. We didn't know each other back then, but
okay.
I was working in VMware and we were doing an integration between vRealize automation and Tanzu. Tanzu had a nice observability platform called Wavefront, and they were competing with an open source observability platform named Grafana. This was the point where I first heard of Grafana. Making a comparison back then, and no offense to Tanzu, but Grafana's functionalities were far superior. And this is how I got hooked. This is what promoted Grafana to me.
Which year are we talking?
This is 3.5 years ago. So let's say for the sake of clarity, 2021, somewhere between 2020 and 2021.
Okay.
So having Grafana in my interest, the winds blew me to that direction. And when I saw that there was an opening for a senior product manager at that time, I applied. And here I am, 2.5 years later, now knowing Pete, one of the backbone, if not the backbone engineers behind Kubernetes monitoring Grafana Cloud. We're here. Pete, tell us your story.
You're too kind, Vasil. Yeah, so as Vasil mentioned, I also came out of VMware. My path is a little different, where I've worked for such a wide variety of different kinds of software companies. I've worked for large enterprises like VMware. I also did enterprise scale backup software for a moment. And everything down to very small, single digits, double digit companies doing research and even medical device prototypes. So I've seen a little bit of everything. Most recently, when I was at VMware, again with Vasil, but we didn't know each other back then, I was doing technical partner management. So I was working with other companies, trying to make sure that their software worked really well on our platform. And it was really exciting to be able to work with other companies and see what was going on out there in the world. But one of the things I wanted to do is I wanted to learn more and build more on the Kubernetes ecosystem. And I wanted to get back into core development. And so that's where I came into Grafana, where now I'm, as Vasil mentioned, I'm an engineer on the Kubernetes monitoring squad and really enjoying what we get to do there.
All right. Yeah, quite fascinating. And yeah, Grafana is just really popular, used by everybody pretty much who uses Kubernetes. And it's pretty much, it kind of owns the space, it defines the space, you could say. It's so popular, but just to set the context, could you define for us one of the key terms that we'll be talking about today, which is observability? If you could define for us what is observability and how it differs from traditional monitoring, that would be a great starting point.
Of course. Yeah, I would be happy to do that. So if we go back in time, like 15, 20 years back in time, We had Excel, which you can feed with a bunch of data, and it can give you a graph. This is the easiest way to define monitoring to the point. You provide it with any kind of data, it provides you a graph. Whether this graph is usable, whether this graph is in context, whether this graph means absolutely anything to anyone, is upon you to build and decide. Now, the easiest way to define observability is having the signals bubbled up from the noise into good enough context that promotes action. In easier terms, this is indicators that indicate a different state of a different system, alerts, which alert you to do an action, automations, which make the actions far easier or non-existent, proactiveness rather than reactiveness, and finally, a really easy way to start. And I'm sure that Pete will touch upon the easy start, because if you're unable to start easily with observability, you're going to be forever stuck with plain monitoring. So monitoring is taking all of the signals and throwing it on the screen. Observability is helping the professionals do what they need to do, or even do nothing in a perfect world.
I think that's a really good point, Vasil, and you touched on the easiness of it. I think that highlights some of the challenges that we try to face through Grafana Labs and trying to make observability an easy thing for other users. One of the things that that we need to, I always remind myself, is that the people who are using our software, they're not observability experts. They're not the ones who are in the software all the day long. They want to use this tool to make their job easier. They want to use this tool to understand what's going on within their systems. And so it really shifts the challenge onto us to make sure that it's an easy thing to get started to deploy onto your Kubernetes clusters. There's so many different distributions of Kubernetes out there. They have so many different requirements and constraints. OpenShift often comes to mind, is because it has a lot of additional security restrictions on top of it, which is a good thing. It drives the community forward as far as making things more secure across the board. And so trying to come up with a solution, an observability solution that works seamlessly with all of these different platforms, that allows you to show them all side by side. You can see your OpenShift clusters next to your EKS clusters, next to your GKE clusters. And to the user, they just say, oh, here's all of my Kubernetes. But behind the scenes, there's a lot to make sure that all of these things look cohesive together.
Oh, great, fascinating. I wanted to get into a bit about like the kind of most common use cases, the most frequent use cases, and probably even a starting point, like you mentioned. But what even triggers that starting point? That someone says, "Hey, I need something that can help me with observability." And what are some of the most frequent use cases that you see bringing more and more users to Grafana? And another part to this question would be, when it comes to observability itself, what are some of the most common challenges that people face with Kubernetes? And those are, in other words, what are the kind of triggers that bring people to something like Grafana?
I can take it. There are three things that can trigger you to observability. One is something failing. If something fails and you don't know what fails, you need to observe it and make sure that you're prepared, or at least when it fails, you need to know what failed. The second thing is something succeeding. Like, for an example, your micro startup succeeding to the point where you now have, let's say, 100 clusters with 10, 15, 30 nodes per cluster, and God knows how many pods and containers. When this happens, when you scale, you cannot, and you should not, hire all of the people straight away so they can patch the gaps and make sure that everything is in place. Even if you have the capital, even if you know the people, it's smarter to actually do observability do automation, know what's happening in your fleet, optimize it well enough, and then maybe hire the people, train the people, and have a nice ecosystem where developers develop, where SREs monitor and systems work. And the third thing is when you start running out of cash. If your system, and as we know, the answer to 99 out of 100 questions usually is money. So if the money starts going away, if let's have the Kubernetes context, if your fleet is losing 70% of your money into cloud resources, if your bill to the different cloud providers is so high that it is threatening the existence of the same startup, these are the 3 times that you need. These are the 3 triggers for observability for me.
Mm-hmm. Yeah, no, I think that's really well said. I was reminded by a talk that another Grafanista, Nicole Vanderhoeven, gave at KubeCon recently, and it's about observability just by itself. Just seeing the data is only half of the challenge. Being able to use that observability data to actually solve problems, that's where the real value comes in. You know, whether that's alerting so that you know when things are broken, or whether that is just a better understanding of the where things are going as far as the trajectory of your users and your usage, so you can do better planning. That's where things really make a difference. And then the cost stuff, Vasil mentioned cost. That's a really important thing, especially for enterprises as they grow larger and larger. They need to also predict, what's the money going to be for using all of these resources. And it goes beyond just what's my bill for my, the cloud providers that I'm paying or the clusters that I'm running. A lot of these customers go even deeper with that. So you could have a company that is using a Kubernetes clusters, and they are billing different workloads within those clusters to different teams, either internally or it's to their customers, and they're doing kind of a subleasing type of thing. And so the cost challenge is a really interesting one, because you need to be able to attribute costs within the Kubernetes cluster down to sometimes the namespace level, sometimes even deeper to individual workloads. And then, even beyond Kubernetes, you're looking at the clusters themselves, but also some of the services that those clusters are using. If you're using hosted databases or other services from these cloud providers, how do you mix all of those things together, attribute them properly, and then build the observability platform around that? There's a lot of challenges there.
And even on top of it, if we're thinking that between, let's say, 30 and 60+% of all of the resources around Kubernetes and cloud resources go to waste year after year, actually things are going better. We have marked down from the 60% point of 2022, and we're going more to the 50% point, which is nice. But at the end of the day, these are resources. This is energy, this is carbon that it is emitted. So you're doing harm on so many levels. You're doing harm to your organization, because the money that you spend on, let's say, cloud providers, you can spend to fascinating engineers like Pete and, let's say, product managers or documentation people or UX, etc., that will make your products such that people love and that work for your business. This is a hidden quote from a nice book. Then if we go even further down the road, you might be not attributing resources well enough in your clusters, in your nodes. So you can have the people in America being happily developing with a 60% resourcing overhead, and the people in Canada, which are exactly next to them, having a huge problem and having their pods and containers CPU throttling all the time because you didn't allocate resources well enough. So it's a continuous loop, a rabbit hole, where without the sufficient amount of automation, opinionation, and setting and following the Kubernetes best practices, you're going to have a bad time. And if you're having a big Kubernetes fleet, you're going to have a bad time at scale.
Well, yeah, and I wanted to highlight, Vasil, you mentioned this, the idle problem, right? Some companies may see I've got idling services, they may see this as I've got headroom, right? But that is a lot of CPU. That's a lot of actual energy, watts, and a lot of dollars that are being used just to keep fans spinning, just to keep CPUs idling. If there are ways that observability can help detect those things, especially if you've got a cluster that's sitting 90% idle, you are wasting a lot of money and a lot of energy on that sort of thing. And so if we can detect those things, because those things won't show up as broken services. They won't show up as alerts. They won't show up as complaining customers. They will only show up when you look at your bill and go, I'm spending a lot more than I'm actually utilizing. So
Yeah, some great examples there. And seems like, you guys are touching on challenges like just availability and reliability, but also interesting things like cost optimization, which is a very high priority these days. Some interesting points you guys made there. But when it comes to Kubernetes, what do you guys think about, in terms of what's the same and what's different? Because there are some things that are kind of the same from, from back in the days of pre-Kubernetes to now that don't change, which also needs observability. And there are some things that are new and different with Kubernetes. Could you comment a bit on that? What's the same and what's really new?
I think one of the things that's definitely the same is that what we all care about, especially myself as an application developer, I care that my systems are running. I care that my applications are running healthy. I care that when things are not running well, that I understand quickly what's going on. I want to be able to get to logs or, look at traces or profiles or something that helps me understand very fast what's going wrong. I think some of the things that are different is that since the rise of Kubernetes and the rise of cloud platforms and things like that there's been such a shift away from the infrastructure layer. Most of the times, a lot of times, if you are paying a cloud provider, you don't care about those things. You're not racking servers, you're not wiring network gear or anything like that. You're not dealing with air conditioning and cooling. I think that there's also a shift towards more of the platform as the kind of infrastructure layer that people are interested in, especially once you get into larger and larger enterprises where you're enabling more of your application developers. The observability challenge doesn't become about the hardware, it becomes about the app development platform and how are things running there. But Vasil, I'd love to get your perspective on it from the PM.
Yeah, I would put it quite easily. For me, the biggest difference between then and now is speed. Just one thing, speed. Autoscalers can scale up so quickly that you might be having a huge inflated bill in seconds. Let's not say seconds, but a little bit longer. On top, I would say a lot of, and this is touching the app platform topic, AI workloads going into Kubernetes and having the need of GPUs. Oh no, what are we gonna do here? Now, even if we're going away from the air conditioning and physical servers paradigm, there are a lot of GPUs that go to waste because there was insufficient amount of, let's say, cooling, because we didn't check the errors, because we didn't know what to do, even behind the abstraction of Kubernetes. So we're talking about speed and scarcity of resources, which sounds the same as, let's say, VMs, but it's far quicker. So if we need to have an analogy, this is the comparison between a town car. My first car was a Renault Clio. I don't know if this is okay to say, but with a Renault Clio and a Red Bull F1 car. So this is things can get pretty hairy pretty quick.
Wow, so amazing stuff right there. I think if we are ever to convert this long podcast into reels, I think there's a lot of stuff in there we could do for 10 seconds, 15 seconds that you guys are throwing out. So really good stuff there. Keep it coming. So I want to ask about, when I think of people thinking about observability and listening to this, I think there could be two groups and there may be even more, but I'm thinking of the group where they know that they have observability needs and they're already looking, searching, trying to improve evolve from where they are. But there's another group that's probably comfortable where they are and probably may not even be aware that they actually need something better when it comes to observability. What could you talk to, the second group in terms of like, what are some of those examples where someone could be managing with outdated observability tools and solutions and not be that much aware about it, but they actually should be alarmed and should actually think of alternatives. Could you give us some examples on that front?
Yeah, I would give two suggestions to these people. It is fantastic that you're currently having a good time, and my first suggestion is continue having a good time. But my second suggestion is experiment. The key to prosperity is experimentation. You need to know what you have on your plate and how you can make it better. So the people that don't need observability, I would reframe it to people that have satisfied observability needs currently. So be on the watch, make sure you have all the gears and buttons and levers to forecast when will this moment of time come when you need more mature observability solutions. Currently, and I don't want to turn this straight into a Grafana Cloud kind of a talk, but you need a supplier, a vendor that will provide you with the means to grow together. What this means is when you start in your garage, you need someone, a trustworthy partner that can stay with you till the point that you scale. Because the moments we're changing, for an example, the observability provider, or when you have to learn a new language to observe, or you have to change everything from scratch, can hurt mostly when you're doing a transition in your business scale. So have this in mind, prepare yourself, don't get into a vendor lock-in, look for vendors that can give you something OSS from the beginning, so you can use it, so you can bootstrap your business and then grow with you little by little without bombarding you with visualizations, metrics, and things that become shelfware. I have a saying that observability done badly is a lot of shelfware software. And that's it. If you're not looking at the little widget on your screen, this is shelfware. If you're doing 110 queries that no one needs, this is again shelfware. If you're doing 10x the metrics that you should be doing and cannot cannot wave off some of them, like with something like adaptive telemetry, let's say, again, this is shelfware. Stay away from shelfware, grow with your observability provider, and yeah, have your observability needs satisfied where you are. Pete?
Yeah, just one little story. So, Vasil mentioned using an observability partner that can help kind of grow with you. The first time that I started, a long time ago, the first time that I actually used Grafana and the whole Grafana stack to observe something that I cared about. I was running a little Kubernetes cluster out of old computers in my basement. And it was two relatively good-sized machines. And then I thought, hey, this will be fun. I've got an extra Raspberry Pi. I'll throw that into the cluster. And I'm like, well, I got 3 nodes. I'm going to set up kind of a distributed control plane. So each one is part of the control plane. I thought it was so cool. And it was humming along, and I was hosting just even like a little blog post software on there. And then one day the dreaded thing, I go to the website and the website doesn't load. I'm trying to figure out what's going on. Ultimately, I figure out that this poor little Raspberry Pi trying to keep up with the other big boys is part of the control plane, and it had filled up its RAM. It had fallen over, taken down the control plane, which took down the whole cluster. And so I'm like, oh man, well, I got to get this thing back online, and I got to install something so I can understand what's going on. And I started down the road of installing all of the pieces one by one, the databases and Grafana itself for visualizations. And it was going to work fine, but I was just thinking, this is a lot to install on my little cluster. Now, again, this is just a little hobbyist cluster. It doesn't really compare to actual enterprises, but I'm installing a lot of overhead just to look at a Raspberry Pi, essentially. And so that's when I started working with Grafana Cloud, and I just installed one agent onto the cluster, and then all of the observability side of things is taken care of. There's a clear benefit to doing that sort of thing. It offloaded all of the responsibility on my part to install and manage these databases. It let my cluster go back to what it was, which is just posting a little silly blog, but it was a much simpler footprint for something like that. So there's a big benefit for just working with a partner who can do some of this observability stuff, and it saves individual developers or DevOps folks or platform engineers from having to manage all of that sort of complexity.
All right. Wow. So I kind of want to get to talking a bit about what you guys are building over at Grafana, what you're working on. And to get into that, I was wanting to ask about, as you mentioned at the start, at Grafana, you try to make observability easy, and that's like one of your main focuses. And one of the things that comes to mind when you say the word easy comes up with any software tool is, okay, it's probably a simple tool which doesn't do much. But how do you balance this balance with, making sure everything is intuitive and easy to do versus you can also do hard things with it if you need to. How do you really walk that fine balance?
I can tell you a story now, if it is story time.
Mm-hmm. Yep,
So
yep.
it is a story about myself. I haven't grown into a really wealthy family. So not during all of my life, we were blessed with enough cash to run with. At some
Mm-hmm.
point, there is a trip organized by the school where we need to pay. The currency in Bulgaria is lev, so we need to pay 10 leva to go on this. I have saved enough, but on a Friday afternoon, I have only 9 leva. So I call my mom and I say, Mom, I don't have 10 lev. I have only 9. She said, ask your best friend. My best friend gives me 1 lev. I pay for it and we're all happy. I go back home and she tells me he is really a really good friend because he understands timeliness. And the reason why I'm telling you that is the same as Kubernetes monitoring and the idea behind building it. Timeliness is that everything that you need into the exact moment is valuable for you only in this exact moment. If my friend gave me 1 lev on Tuesday, when the excursion, the trip was going to be over, it wouldn't mean anything to me. But on this Friday afternoon, it meant the world. So an alert for a crash looping pod after a release on a Friday afternoon can mean the world to you. This is how we build it. We're trying to blend Kubernetes best practices, which is the context which I was talking in the beginning, with all of the goodies that Grafana Cloud provides, like SLO, machine learning, alerting, incident management out of the box, scenes tables with a lot of different functionalities tailored into Kubernetes best practices context. So we can give you the things that you need, the things that can tip the scales either strongly in your favor or strongly against it. And finally, of course, the easy to start part that I'm hammering from the beginning. Pete, tell us how important it is for people to be able to start easily with the thing that you're building.
Yeah, and something that I mentioned earlier about so many different types of Kubernetes clusters, different platforms, different requirements there. One of the things that we've worked really hard to build at Grafana Labs is a method for getting started, for getting something onto your clusters that can gather this telemetry data, package it up, process it, and send all of that data up to Grafana Cloud or to a different database. We've built a Helm chart that wraps a lot of not only the collector, but a lot of the best practices that we've learned as far as monitoring Kubernetes clusters. Things like let's only collect a subset of the metrics that you need. You don't need every single metric. You only need the ones that are really going to be important for you for monitoring your Kubernetes clusters. We can get rid of the rest of it. That automatically will save you some money. That will save you some storage cost. We know how to parse log formats from different service providers so we can understand a little bit more richly in depth of those log messages, what's actually being communicated. We can pull out things like error messages so we can highlight, oh, hey, there's this errors that are coming up. because we've understand the kind of logs that are coming through. And so we've built a lot of that wrapped into a Helm chart so that it makes it really simple to deploy. And the thing that I'm really proud about of this Helm chart is that it works really great for very small 3-node clusters that maybe, a little engineer has in his basement or something like that. But it also can scale all the way up to multi-thousand node clusters for enterprises. We've put a lot of effort into making this a really useful tool for anybody who's running Kubernetes, no matter what size of cluster that you have, and a lot of customizability that's built into it too.
All right. Wow, powerful story there, Vasil. And so we've covered a lot of ground. We've spoken about the key terms, the background, the challenges, and the reasons people would need observability. We've even spoken about kind of the approaches to do observability the right way. And you guys have also mentioned Grafana's approach to observability. I was wondering if we get to actually see all of this come together in a little demo that you have for us, just showing us what you guys have been building and working on recently, and what's new in Grafana, or what's important for us to know and see about Grafana.
Phenomenal. I can do that. This is what I do for a living. This is how I bring bread to the table.
Go for
Oops.
it.
Okay. Just tell me once you're able to see.
Yeah.
Fantastic.
Yes.
If you need to remember 2 things out of my demo, the one thing is play.grafana.org. This is entirely free for you. Go and play grafana.org and just play with Grafana. And the second thing is your first screen will look like that. So make sure to click on the Grafana menu on top and pin it and pin it. Dock the menu so you can see all of the goodies on the left-hand side that Grafana offers. Under infrastructure, when you click here, you'll see Kubernetes monitoring. And this is what we were talking about. I don't know if it was too fluffy, but I will try to put some perspective behind it. In Kubernetes monitoring, the first screen always tries to direct you to how your fleet looks, the amount of clusters, nodes, namespaces, workloads, etc., how your overall CPU and memory utilization looks like, and bubble up the signal from the noise. Here you have container and pod alerts. So if we imagine that I clicked once at Kubernetes and I see a crash looping pod, when I click on the container, I'll be able to see it and I'll be able to recognize how many restarts it had, maybe even see some logs and events side by side. So whenever I open it, I should be able to see, yep, it's a backoff restarting failed container. 3 clicks and I have some meaning behind it. But this is not the only beauty of Kubernetes monitoring. Again, we have an attribution from cluster to namespace to workload to node. And we have an attribution for both the compute, which is CPU and memory, split between average and maximum, so you can have a better idea of what is happening. You see all of your providers, as Pete said. You see GCE, we see AWS, we can see a lot more. And cost attribution on top. So you can see your current compute price, the projected price for 30 days, and you can see also your CPU and memory idle costs, which is fantastic. And this is the same, and it scales quite nicely for namespaces. Again, usage and cost, workloads, fantastic, and nodes. I can show you something. Hopefully it's gonna work flawlessly. We have something new. It's called the certs, and the certs workbench provides you with the phenomenally intuitive automation about finding the root cause. So I'll just select those 2. These are nodes. A nice button appears, says compare nodes in workbench. You click it and you see trace like time here that shows you what happened during time with the little alerts that you're having. You can expand them. You see a container crash looping and the pod crash looping. You can observe them in the KPI dashboard. It takes just a second. There we go. If there was some data, if it was not crash looping, it would have some data. But long story short, from here, you can go back to the dashboard, and voila. So going back to Kubernetes monitoring, we have a big cost view, which provides you a quarter of financial data on top of everything else. So we have 30 days prior, total compute costs, percentage change, current 30 days, and a forecast for the next 30 days. So a total of a quarter. We have a savings view where you can see everything, and let me put it 30 days here. So we can see 30 days of data. You can see everything from CPU to RAM to storage to GPU cost during time and how you can manage it and how much cash you can save for yourselves. Finally, going back to alerts. Alerts is something that is a lot in Kubernetes. There's so many pods, there's so many namespaces, there's so many containers, and they all spill alerts. So at some point, you get these. You need to know more about one of your clusters. Maybe not that one, but maybe this one. Yeah, why not this one? And severity. I need the highest severity, so I'll just pick warning, and voila, I have the 3 most important alerts in my cluster. And cube job not completed. Oh, pod crash looping. Okay, I want to go to the pod. Where is the pod? Here is the pod. I click on the pod. I can see it. I can see that we have CPU requests set, but we don't have CPU limits set. I can go even deeper to the container level, where I'll be able to see linear recommendations for CPU and RAM. I'll use the RAM one because the CPU has not been set, but currently, for an example, the current container limits are 250 megabytes. The recommendation is 23 megabytes. So sad. So you're paying quite a lot for memory that you're not using. There you go. Again, everything from alerts to usage to cost to a deep drill down from cluster. Did it just visualize? Give it a second. It's a huge cluster. There we go. To CPU requests and limits, we see 160 containers. To predictions, we have ML predictions. When you hit that, it's going to do a machine learning prediction and show you how would your CPU look like in time. There we go. To a complete attribution, again, usage and cost for nodes into this particular cluster, and a drill down straight to the container. We're going to do this pod, and finally this container. That's it.
Right.
Have I forgotten to show something?
No, it looks great. One of the things that I really appreciate about the work that the whole team has put into the Kubernetes monitoring project within Grafana Cloud is how it really solves problems for multiple different types of people who are looking at it. You've got the people who are managing the clusters, and they care about the strength of the platform and the alerts about the platform, as well as the cost and the utilization of that platform, of those clusters. But it even works for the people who are just doing the app development. I don't really care about what's happening in all the other namespaces. I care about my namespace. I care about my application. I want to see those logs. I want to see those events. And I want to make sure that when I'm picking the CPU and memory requests and limits, that it's pretty accurate for what actual workload is looking like.
And just one addition. We were talking about Easy Start all this podcast, and we didn't show it. So here is where Pete's magic comes in, the configuration. So it is a standard click here, click there, easy to navigate, but genuinely, you pick anything from EKS to EKS on Fargate, OpenShift, and IBM Cloud. Let's pick this one. You pick the set of metrics you want. Cost, energy, Zipkey and OTLP. You can just toggle these toggles. Finally, you have a Helm chart that you can easily execute with Terraform at scale. It's extremely, extremely easy. And it makes sense because it works the same way as it works on GKE. It works the same way as it works
Ah.
on Azure AKS. Go ahead.
Amazing. That's awesome. Yeah, I love how it's all connected so well and that you can click through, and though there's a lot of data, it's definitely not it's not overwhelming, and you can easily get to what you really need to. I want to ask about the example that Pete was talking about, where if it's an app developer and they just care about their own namespace, not all of the others, what their team is working on, and they want to see just that. What are some options for customizing the views, maybe creating your own dashboards, or maybe adding some labels or tags or that sort? I'm sure there's a lot we didn't explore, but if you could just show us something that's possible on this front, we'd love to see that.
Yeah, no, that's a great question. So as far as customizing the views, one of the really cool things about what we actually put onto the Kubernetes cluster through that Helm chart that Vasil is showing is that all of the data that we gather, all of that data goes into the databases, the time series databases and the log storage databases and all of that. And that data is still available to you. So you can do so much more than just use the Kubernetes monitoring application to view that. You can then build all of your custom applications on top of that. I've seen people build some really interesting and rich dashboards that serve not only from the infrastructure and Kubernetes view, showing what's going on just for the places that they care about, but business logic. How do you tie together the pod lifecycle to actual sales being performed and things like that? And so all of that data is there for you. I also mentioned that the Helm chart that we deploy, it's supposed to work really great for small clusters to large clusters, and there's a lot of places where you can add configurations. With just a few additional lines, you can scrape metrics from all of your applications. You can get custom business logic metrics from within your applications or other services. You can add labels to all of the things that are coming in there. You can then use those labels to attribute for different teams, different development teams or things like that, and then build even more rich dashboard experiences based on that sort of stuff.
All right, got it. We're kind of coming to the end of our conversation, but one of the last things that I wanted to touch on is integrations. And so could you tell us about, the most common integrations, plugins that are available that people use, and some of maybe even the new exciting ones that have been recently added?
This is a really good one. This is a really good one. We have so many of them, and I will use a cheat sheet. What we define as integrations is scraping rules, alerts, and dashboards that come out of the box in Kubernetes Helm chart, in Kubernetes monitoring. We have everything from Aerospike, CouchDB, Couchbase, etcd, Nginx, almost all of the control plane fleet, InfluxDB, MySQL, PG Bouncer, Presto, OpenSearch, IBM DB2, which is something interesting, CockroachDB, Apache Tomcat, just name it. We have the majority of them. So these are things that we actively work on. Cilium, I should not forget Cilium, but maybe it's a good place to say that apart from the different integrations that we're having, we're also compatible with OpenTelemetry, with our distribution of Hotel Collector named Alloy, which is integrated deeply into the Helm chart. You can do OpenTelemetry as well with Kubernetes monitoring, with the Helm chart, using your own dashboards and anything of a sort.
Right. Yeah, and like what Vasil was mentioning with all of the different projects there, some of the most popular integrations that we see, databases. One of the things that Grafana really cares about is making sure that no matter where your data lives, that you can get access to it, that you can observe it, you can understand what's going on there. And so, me playing the role as an application developer, I care about the applications that I write, but I also care about the services that are backing those sorts of things. So if I have a project that is using a MySQL database as the backend, I want to know that those pods are running, yeah, but I also want to look at things like, are the requests being fulfilled quickly? Is the database running optimally for the services that I need? And so Grafana Labs brings a lot of integrations and a lot of customizations on how do you get the data out of that and how do you visualize that without asking the individual users to become an expert on how do you wire those things together. And so some of these integrations, they are built in. We make it extremely easy to get started with that. But with the compatibility with open telemetry protocols, or with just, like I said, a few different lines of code, you can add the metrics from your own applications. You can get all of the data, no matter what format it's in, and then build the dashboards and visualizations around those.
Got it. Got it. All right, guys. Last thing I want to ask is about just looking ahead, the next 1 year or so. What excites you the most? What are you guys reading up about? What are you following on Reddit or wherever else you get your news and information from in the space? What's coming next? Or even for Grafana Labs itself, what's something exciting that you guys are working on that's going to be launched? Anything at all about the next 1 year that you'd like to put out there?
I would want to hit again with two things. One thing is during OpsCon, a new cloud provider observability application in Grafana Cloud was announced by our CTO, Tom Wilkie. It is already there. It is still as a toddler child of mine because I'm the PM for it as well. I'm really excited to see it grow, start working on its own, and hopefully.
Vasil, how do you spell?
Cloud provider observability.
No, I mean,
or Tom
no,
Wilkie.
No, the product, the new product you said that's just been announced.
Yeah, it's called Cloud Provider Observability.
Oh, okay. Sorry. All right. Yeah.
It observes your cloud providers. This is what it does. This is one thing that I'm quite excited about. And the second thing that I'm sure me and Pete are extremely excited about is touching the AI space with GPU monitoring in the context of Kubernetes. But I'll leave Pete talk to it, even though I have a huge urge to do so. But Pete, please take us away.
Yeah, I mean, we've seen how important AI and by extension, the GPUs that are backing the AI training and the AI usage, how important that has been in the rise of that over the last several years. That's going to be only more important of an observability space for people running their AI workloads within Kubernetes, within their cloud systems outside of Kubernetes. And so we're really excited about the potential and the opportunities there to bring the same level of observability for those as we've done for Kubernetes itself, where you can have all of the different Kubernetes clusters and view them side by side. You know, what can we do to make the observability of that of those workloads as seamless too?
Right. Wow. That was a fascinating conversation. Thanks, you guys, for joining and just sharing all of that with us today. It was really fascinating to discuss all of this today about observability and Grafana. Some really good stuff there. Before you go, though, just a question to get to know you a bit more. Just what you do apart from work, maybe. Could you tell us what would be your alternate career path if not for your job in tech?
That's a great question. I think that there's a story that I think about a lot every once in a while. It's there was a time when I was walking into a building from a company that I was working in, and I happened to be walking in. I'm an associate software engineer. I'm fresh to the industry, and I'm walking in at the same time as the senior director who's working in the building, and we happen to be walking in at the same time. And while we're still in the parking lot, we look over and there's a gardening team that are putting in new flowers. And the senior director leans over to me and she doesn't even know my name. And he goes, "There are some days that looks like a really good job." And I don't disagree with him. As you see in my background, I've got a lot of plants, and I joke that my office becomes the office for misfit plants because it's all of the plants in the house that are kind of wilting. Maybe they're on their way out, but I'm like, no, they're still good. I'm going to keep them in here. I'm going to nurse them back to health. And I just love having plants around. So maybe alternate career, if I couldn't be in tech, would be, running a greenhouse somewhere, just being surrounded by plants. like I said, I'm in Minnesota, so for a good chunk out of the year, it's cold and it's gray, and so I just love having as much green around as I can.
That's peaceful. Do you have a favorite plant out there?
Let's see. So I used to be into orchids. I'm kind of less into orchids right now. I'm really liking this one here. This is we got a Dracania right here. And this is one that was about half the size when I first got it. And I just think it's kind of funny because it looks like a guy who's just sitting like this. So.
Wow. Awesome. My wife loves orchids too, by the way. Yeah, purple her favorite color. So, all right, really cool. Vasil, what do you do?
I would say that I have always had a fascination with teaching. So if not tech, then maybe I would either teach or hopefully someday own a school or a university. Why not? Dream big. Or yeah, go big or go home. That's where I imagine myself and what I really would be doing, if not this.
Yeah, I think it would totally fit you considering the amount of real-worthy quotes you've given us today. But if I have to push it a little more, if not for teaching tech, which is the most interesting subject you'd like to teach?
I really adore cars. So
Okay.
maybe we can go that way. Maybe we can start from kartings, little kartings. I really like to take my two kids going karting. This is go-karts in American English. I do apologize. So go-karts is something that I would like to do. I would start either teaching them or having them making races, calling more kids and their parents and having a good time. Such a dream. Such a dream.
Wow. Yeah, that'd be a fun childhood. All right, guys. With that, we come to the end of our conversation, and what a pleasure it was to have you guys on the show. Just loved listening to you guys, and you did a fascinating job of just talking about all things observability and just getting us excited about what Grafana is up to. Definitely come by again next year sometime whenever you're releasing something big. We'd love to hear all about it, and we'd love to have you guys over again. You guys make a great combination on a podcast.
Thank you so much. I had a fantastic time.
Thank you, Twain. It was fantastic. Phenomenal.
Okay, and thanks to all of our listeners and viewers as well for tuning in. We hope you loved listening to this as much as we did recording it, and we'll see you on the next episode. Bye-bye.